Given each function, evaluate g of x plus h minus g of x over h, with h not equaling 0. We just have to make sure that we don't plug 0 into the denominator of a fraction there. In the last video, we were calculating f of x plus h, and I mentioned that that would show up in another problem later. This is one of the problems. This fraction here is called the difference quotient. It is used to calculate slope of a graph in calculus. So you'll see it later for those of you that are going to take business calculus. We have already got g of x, which is this part of the expression. What we need to calculate, though, is that other part there, the g of x plus h. So let's figure out what that is so we can plug everything in. Let's start by finding g of x plus h. Wherever I see x in my original function, I'm going to exchange that for with x plus h. So I'll have 5 minus, I'm going to put x plus h in the space here and then square that. So inside the parentheses, I'm going to have x squared plus 2 times x times h plus h squared. All right. Next, I'll distribute that negative sign. So we'll have 5 minus x squared minus 2xh minus h squared. All right, now we're ready to plug in the two components. So g of x plus h. Let's make a different color here, minus g of x. And then that whole thing's going to be divided by h. So I'm going to start with this. This is my g of x plus h. 5 minus x squared minus 2xh minus h squared. And then I'm going to subtract off g of x, my original function, 5 minus x squared. Notice that I put parentheses because I want to make sure to distribute the negative sign to all of the items. And then the whole thing is divided by h. Now, if you've done this process correctly, one thing you'll notice is that a bunch of things will cancel. I've got 5 here, and this is going to be a subtracted 5, so those two are going to go away. I've also got a negative x squared here, and this will end up being a positive x squared, so those two items are going to cancel each other as well. So everything in that second set of parentheses should actually cancel. So it looks like what I've got left is negative 2xh minus h squared, and the whole thing is being divided by h. So now we're to the second part where we make another check to make sure that we're on the right track. The second thing that will happen is in the numerator, we should be able to factor an h out of all of the terms that are left. And we like that because now we can cancel the h in the numerator with the h in the denominator, and we don't have to worry about potentially plugging 0 in to this. So it looks like our final answer here is negative 2x minus h. Let's do another example. We need to calculate first g of x plus h. This one's going to be a little bit more tricky because I've got x in 2 locations. This will be x plus h squared plus 2 times x plus h. Again, anywhere that I have x in the original, I'm instead plugging in x plus h in its place. All right, let's expand this. This will be x squared plus 2xh plus h squared. Distributing the 2, we have plus 2x plus 2h. All right. Now we're ready to put together our difference quotient. G of x plus h minus g of x divided by h. So we'll start with this. And then we'll subtract off this. And then the whole thing is divided by h. All right. We said that one of our first checks is that everything that's in this second set of parentheses should cancel with something else. So that x squared is going to cancel with a negative x squared. And then I've got a 2x here. It's going to be a minus 2x. It's going to cancel with this 2x. All right, that looks good. So what do we have left? 2xh plus h squared plus 2h. And we said our second check was that everything that's left in the numerator should have an h in it that can be factored out to the front, so that we can cancel it with the h that's in the denominator. And our final answer here is 2x plus h plus 2. For example 4, we are going kind of in the opposite direction. We are given a function and we want to figure out what are the input values that would give us a particular output value. We're being told that our output value is equal to 2, and we want to know what were the x values that led to that output value. So what I'm doing is in my original that's given, instead of writing f of x, I'm exchanging that with a 2. I'm putting 2 in its place. So I want to try to solve this, and this is a quadratic. And the strategy that we learned is to move everything onto one side and 0 onto the other, so that we can either factor or use a quadratic formula. It looks like this one factors into x plus 2, x minus 1. And now I can split this into two separate equations. We have that either x plus 2 is equal to 0 or x minus 1 is equal to 0. This first equation gives us x equals negative 2, and the second one gives us x is equal to 1. So it looks like I have two different values that if I plug them into the function, I'll get an output of 2. We know that this is a parabola. The parabola looks something like this. And so this is saying that when I plug in negative 2, which is over here, or 1, which is here, they both have the same output value of 2. That's not drawn very well, but you get my idea. All right, let's look at another example like this. We want to know what is the input value or values that will lead to an output value of 4. So instead of writing f of x, I'm going to write 4 is equal to the square root of x plus 2. I want to square both sides of this equation so that I can get rid of the square root symbol. So I'll have 16 is equal to x plus 2. And then if I subtract 2 from both sides, I'll have that 14 is equal to x. This function is a graph that looks like this. And so it's saying that when we plug in 14 for x, the output value that we're getting is 4.